Imagine floating. No sound, no sensation, no weight. Just darkness in every direction, stretching forever. And then, you start to disappear. Not dramatically, not instantly. Slowly, quietly. Like a candle being swallowed by an ocean. Because the universe is stealing something from you. Something you never thought about. Something you've taken for granted every single second of your existence. Your warmth. And here's the part nobody tells you. The part that will completely change how you see the night sky by the time this video ends. The cold out there, it's not just extreme, it's wrong. It behaves by rules that don't exist anywhere on Earth, rules that turn your instincts completely upside down. And the most terrifying thing about it, it's not going to stay out there. It's coming for everything, including us. I'll explain exactly what I mean at the very end of this video, and I promise you, once you hear it, you will never look at the sky the same way again. But first, quick question before we dive in. Where in the world are you watching this right now? Drop it in the comments. I genuinely want to know. Now, let's rewind, and let's start with something you think you already understand. You've been cold before. Maybe it was stepping outside on a January morning when the air hit your face like a wall. Maybe it was jumping into a lake that was colder than you expected. Maybe it was sitting in a car that had been parked overnight in winter. That specific deep cold that soaks through your coat in seconds. You know what cold feels like. And so when someone tells you space is cold, you scale it up. You imagine a really, really, really bad winter times 1,000. That's wrong. And it's wrong in a way that matters. Because cold on Earth works through 3 mechanisms: conduction, convection, and radiation. Conduction is what happens when you touch ice. Heat flows out of your hand directly into the colder object. Physical contact, energy transferring from molecule to molecule. Convection is wind, cold air rushing past your skin, stripping heat away. It's why -10 with no wind feels survivable, but -10 with a gust of 40 miles an hour feels like your face is being removed. Both of those require something to move through: solid, liquid, gas, matter. Space has almost none. In the vast emptiness between stars, in the regions that make up most of the universe's volume, there is roughly 1 atom per cubic meter. 1. Your bedroom right now contains 27 trillion atoms per cubic meter. The best vacuum chambers ever built on Earth, pumped down using the most powerful equipment ever made, still hold billions of atoms per cubic meter. Deep space holds 1. That means conduction doesn't function out there. There is almost nothing to conduct through. Convection has nothing to work with. The mechanisms your body depends on to lose heat simply don't operate in the void. What remains is radiation, invisible heat escaping outward as electromagnetic waves. Your body does it right now. You're glowing in the infrared constantly, releasing heat into the room around you, receiving it back from the walls and furniture. In space, you'd radiate outward, and almost nothing would radiate back. Almost. Because in 1964, 2 engineers at Bell Labs in New Jersey were trying to do routine radio astronomy, and they kept picking up a noise, a hiss, everywhere they pointed their antenna. Every direction, every time of day, every season. They checked the equipment, they blamed New York City, they ruled it out, they found a pair of pigeons nesting inside the antenna, cleaned everything, and checked again. The hiss remained. What they had accidentally discovered was the cosmic microwave background, the faint, cold afterglow of the Big Bang itself. Light that has been traveling through the universe for 13.8 billion years, stretched so thin by cosmic expansion that it had cooled from billions of degrees down to almost nothing. That background fills all of space, Every cubic meter of the observable universe is bathed in it equally from every direction, and it corresponds to a temperature of 2.725 Kelvin. To understand what that means, you need to understand temperature itself. Temperature is not a thing. It's not a substance. It's a description. It measures how fast the particles inside something are moving. Hot means fast. Cold means slow. Boiling water. Molecules colliding hundreds of times per second. Chaotic, energetic. Your kitchen freezer. Molecules slowed enough to lock into the rigid crystal structure of ice, but still moving, still vibrating. There is a point, a theoretical floor, where particles would have no thermal motion at all. Zero kinetic energy, zero vibration, the absolute minimum. That is absolute zero, minus 459 degrees Fahrenheit, the coldest temperature that can exist. Below it, temperature itself stops having meaning. The background temperature of the universe, the baseline cold of open space, sits less than 3 degrees above that floor. 3 degrees. The difference between a glass of ice water and a cup of hot coffee is 100 degrees. The universe's background temperature is within 3 degrees of the point where thermal motion itself would stop. That is what space is. Not cold like winter, cold like the edge of physics. And here's where it gets strange, because 2.7 Kelvin is not even the coldest thing out there. In deep space, there are dense clouds of gas and dust called molecular clouds. Their interiors can be shielded from even that faint microwave background. In those shielded cores, temperatures can drop to 1 Kelvin, 1 degree above absolute zero. The Boomerang Nebula, 5,000 light-years from Earth, has been measured at exactly that, 1 Kelvin, colder than the ambient temperature of the universe around it, made cold by gas expanding outward from a dying star, losing energy as it pushes against the expansion, dropping below even the cosmic baseline. The coldest known natural object in the observable universe. And on the other side of the solar system, the furthest places we've ever visited, the cold is already staggering. Pluto's surface sits between minus 375 and minus 400 degrees Fahrenheit. When the New Horizons spacecraft flew past in 2015, it didn't find a dead, featureless rock. It found nitrogen ice plains, mountains of water ice standing miles high, a layered haze of nitrogen and methane hanging in the atmosphere. Cold doesn't mean empty. Cold doesn't mean simple. Cold produces structures of unexpected, almost alien beauty. And then there's what cold does to matter itself. Not just slowing it down, transforming it. At room temperature, steel bends under stress. It deforms gradually. It warns you before it fails. Cool that same steel to the temperatures of deep space, and everything changes. The crystal structure locks rigid. Apply stress, and it doesn't bend. It shatters. Clean fractures, no warning, no deformation. This is called the ductile to brittle transition, and it has killed people. Metallurgical analysis of steel recovered from the Titanic wreck showed the hull plating was unusually brittle at cold water temperatures. The North Atlantic that night was just below freezing. When the ship struck the iceberg, the steel didn't buckle, it cracked, it fractured. Seams opened that flooding water poured through far faster than they would have with more flexible material. The cold of the ocean didn't sink the Titanic directly, but it changed what the ship was made of. It made a survivable collision unsurvivable. That is what cold does. It doesn't just lower a number on a scale, it rewrites the rules of the material. Now, I promised you something at the beginning of this video. I told you there was a truth about the cold of space that would change how you see the sky, something that turns your instincts completely upside down. Here it is. You think cold is the enemy. You think warmth is the goal, the treasure, the thing worth protecting. And if you're a fragile biological creature standing unprotected in space, that's correct. But here's what physics actually says. Life on Earth does not run on the sun's heat.
It runs on the difference between the sun's heat and the cold of space. The sun's surface burns at roughly 10,000 degrees Fahrenheit. The background temperature of deep space is minus 455 degrees Fahrenheit. The gap between those two numbers, that enormous contrast, that gradient, that is the engine. A universe with no cold would be a universe in thermal equilibrium, a universe where everything is the same temperature everywhere. And in that universe, energy has nowhere to flow. No gradients, no chemistry, no motion, no life. Nothing happens. The cold of space is not just the backdrop to the story of life. The cold of space is part of why the story of life exists at all. Remove the cold, remove the contrast, and the sun's energy becomes useless. Heat sitting in a closed system with nowhere to go. Light falling on a world that can't do anything with it because there's nowhere cooler for it to flow toward. We don't live because space is cold, but we could not live if space were not cold. And now, here is the part that should keep you up at night. The universe is cooling, has been cooling since the moment the Big Bang began. That background temperature, 2.725 Kelvin today, was once billions of degrees. It has been falling for 13.8 billion years, and it will keep falling. Weather systems, ocean currents, photosynthesis, every calorie that powers every living thing on Earth, all of it ultimately derives not from warmth alone, but from the contrast between warmth and cold. A universe with no cold would be a universe in thermal equilibrium, a universe where everything is the same temperature everywhere. And in that universe, energy has nowhere to flow. No gradients, no chemistry, no motion, no life. Nothing happens. The cold of space is not just the backdrop to the story of life. The cold of space is part of why the story of life exists at all. Remove the cold, remove the contrast, and the sun's energy becomes useless. Heat sitting in a closed system with nowhere to go. Light falling on a world that can't do anything with it because there's nowhere cooler for it to flow toward. We don't live because space is cold, but we could not live if space were not cold. And now, here is the part that should keep you up at night. The universe is cooling, has been cooling since the moment the Big Bang began. That background temperature, 2.725 Kelvin today, was once billions of degrees. It has been falling for 13.8 billion years, and it will keep falling. As the universe expands, stars burn out, galaxies go dark. The last stars will exhaust their fuel and collapse. Black holes, which will be the final massive structures left, will slowly evaporate through a quantum mechanical process over timescales so vast that the current age of the universe looks like a rounding error. And eventually, the last black hole will dissolve, the last temperature gradient will equalize, the last useful energy will diffuse into the expanding void, and the universe will settle into a cold so total, so final, so complete that nothing can ever emerge from it again. No chemistry, no structure, no warmth, no exceptions. The cold will win. The cold will be the only thing left. We live right now in what is, cosmologically speaking, a brief window of warmth, a temporary, improbable, wildly unlikely exception to a universe that is cold by default, cold by mathematics, cold by the sheer probability of disorder over order. Every star you've ever seen in the night sky is a flame in an ocean of cold that stretches for billions of light years in every direction. And we are standing on a rock next to one of those flames, warm enough to breathe, warm enough to think, warm enough to look up and ask questions about the darkness. That is the terrifying reality of how cold space really is. Not that it would kill you if you went out unprotected, not that it makes the distances between stars feel lonely, but that warmth, All warmth, every fire that has ever burned, every living thing that has ever existed, every thought anyone has ever had is nothing more than a temporary deviation from the cold that was always there before it and will be there long after it is gone. We are the exception, and the cold is patient.